One common use case that happens quite often in when you're dealing with hierarchical data structures is that it needs to be converted into either a normalized or a denormalized representation. We saw that in relational databases when we were creating views, right, or materialized views that oftentimes we wanted to, depending who the audience was, we had to create virtual tables, right, that were just much more convenient to work with, right? We had gone through the trouble of normalizing our data, breaking it up into multiple tables, with the idea of reducing redundancy so that we would eliminate the risk of inconsistency. But that became, introduced the inconvenience of having to reconstruct the data, from with implementing multiple joins, right? Sometimes 2, 3, 4 joins, to reconstruct and fetch the data, multiple records from different tables. And depending who the audience was, this was very inconvenient for them, right? So to deal with that, what we did is that we implemented a denormalized view, which implemented all these joins for us and represented it in a much flatter representation, as if it were a single table that grabbed data from multiple places, right, and put it in a single convenient table. That's something very common that happens, even in JSON or even in user interfaces. It's very, very common that we transform the data that is being stored in a relational database, in a non-relational database, or in XML, regardless what your data storage solution is. Usually you want to make sure that it's normalized, right? That it has no redundancy, it has no risk of inconsistency. But when you're going to represent it and display it for a user interface, or we're going to share this data with some other enterprise partner, it's often the case that you need to denormalize the data, right, for convenience purposes, okay, or for representational purposes. So let's look at an example where we might want to do that. So for instance, here we have the graduating students on the left-hand side, which it's a fairly hierarchical data structure, right? We have the root graduating students, then under there we have students, and then each student has courses, a list of courses. So it's spread out into multiple elements, and it's very, very hierarchical, right? And we oftentimes associate that with a normalized schema. So let's look at denormalizing that schema. Somebody just wants to, this is the registrar's office, and they want a real quick display of all the enrollments in their college, right? So for instance, we just want to look at all the different courses that were taken. Okay, so to do that, they want to convert this into a denormalized representation. So here's an example of how you would do it. Right? You would go graduating students, go into each one of the courses, iterate over all the courses, and then extract different portions. Right? Go up and down, right, from the different elements. Fetch some data from above from the students, then below, grab some data from the titles. Right? So this is the equivalent of a join. Right? This is the equivalent of a join in a relational database. Right? We are extracting different data across the hierarchy and bringing it together into a single element. Right? So we are in effect denormalizing our data representation, and you come out with the result of just this enrollment that has the courses that were taken. Now, oftentimes you want to do the opposite, right? You are given a denormalized representation, and you want to store it into a normalized representation, right? And an example that happens in user interfaces. This happens all the time when folks, they submit a form, or they go through a wizard and they're filling out different portions of the wizard, or maybe they have a very long user interface and they're filling out this long form. for them, it's just one single thing, right? But for us, when we are going to store this in a relational database or JSON or XML, we have to break it up into the different portions and store it in the right tables, right? And says, well, this is addresses go over there, and this is customer information goes over there, right? And the orders go over there, right? And the product information goes over here, right? So we have to break out, right, the different data that is being passed to us that might be denormalized. We then have to, inside our algorithm, convert that into a normalized representation. So, for instance, we're giving a normalized representation of all the enrollments, but we need to put it back into a normalized representation of all the graduating students. So to do that, so for instance, we're given this, right? We have these enrollments and all the courses of that enrollment, but we know, right, that there's a whole bunch of redundancy here, right? The graduation year, the course taken. Some of these stuff is just repeating over and over. That perhaps there might be a better way of storing this in the database in a normalized fashion. So let's look at how do we do that. So to do this, it's a little more challenging in the sense that, as we're iterating over this, right? Notice that we have a redundancy here that we are capturing Ian 3 times, and Ben we're capturing 2 times, right? Again, because it's denormalized, right? It's we have redundancy and we have the risk of inconsistency, right? It could be that we inadvertently mistype the name of Ian, right, or gets transformed in a different way, and we have the graduation year representing differently. One says 2009, the other one says 2010, which makes no sense that he has 2 graduation years. So this has problems, right? We need to convert it into a normalized representation. So we need to, to convert to normalize this, we need to say, well, this graduation year really is just 1, right? It can't be 3 times. Same thing with Ian. Ian has to be just 1. So somehow we need to be able to group these 3 elements into a single element, right? Represented only once, Ian. And same thing with Ben. Ben would need to be represented only once. So somehow we need to say, all 3 of these are somewhat related to one another. They form a group, a single group, right? That is fed from these 3 original documents, right? So let's see how we can do that in XML. So to do that in XML, what we could do is that we're going to, yes. Oh, let me see. Thank you. See, for some reason it mutes me. That's weird. Okay. All right, so let me backtrack a little bit. Right, so we want to be able to normalize this this data, right? That it's denormalized, right? We have a lot of redundancy. The graduation years is being repeated. The name of the students is being repeated. So we want to make a mechanism that will allow us to. What the heck? What am I doing? Why is it going non-audible? Let me see.
Maybe because of it.
Maybe that's it. Can you hear me?
Yes, right now I can.
Yeah, I don't know what's going on. Yes, please feel free to interrupt me if you can't hear me. So I was saying that we're going to transform this this denormalized representation into a normalized representation. We want to remove the fact that we are capturing the information for Ian 3 times, right? And we want to group it into a single element, right, that captures the information just once. So to do that, we're going to use a very powerful element in XML that allows us to group together several incoming pieces of information or elements, right, into, so it recognizes that they all actually belong to the same group. So we're going to select several course taken elements. In our case, it's these over here, right? We want to be able to grab several of these so that they belong to the same group, EN, right? So to do that, we can say, okay, grab the course takens and group them by this criteria. In our case, we're going to group them by the attribute student name, meaning that these three really should be in the output XML. They should be represented with a single element as opposed to 3 times in the input HTML document. So we're saying, iterate over the course takens grouped by student name and represented only once with a single student element. Right? So the output will be a single student element. Right? When we're generating the student element, we're going to grab the student name, which is there's only one because all 3 have been grouped by this one student name. Also, there's only one graduation year. Okay, now for the courses though, we do want to keep 3 elements, right? Because inside of courses, we have to be able to say that Ian took these 3 courses, right? So in effect, we're taking this something that used to be at the top of the root of the incoming XML document, and we're going to move it down into a subset of a child, right? So in this case, we're going to say, well, inside of students, we have the student names, we have the graduation year, and under there we have the courses, right? And generate one single courses element, but in there generate several instances of course, one for each one element in the group, right? So meaning we're going to iterate, for the current group. The current group is those 3 original course taken elements, right, that are part of the group grouped by the name of the student name. So there's 3 of them. For each one of them, generate a output course. And as you are iterating over each one, grab the title attribute and generate a title element. Grab the year taken attribute and generate a year taken element. And same thing for the grade. So in effect, we're grabbing these 3, year taken, grade, and the title, that are all attributes, and converting them into elements. Okay, and then close the for each group. Very, very powerful. Yeah, so this just reiterates being able to see how they reference each other, going back and forth in the attributes, using the at symbol, right, to refer to attributes.